In this video, we'll be looking at the SAT math topic, solving for x. And this indicates that there are about 4 to 5 problems of that type on each test. These problems are ones where you have to solve for an unknown. And they're the SAT math problems that are most like high school math problems. Most SAT math problems aren't like high school math problems, but these are the closest to those that you'll see in high school. Problem types: translating words to algebra, problems with an unknown on both sides, problems testing the distributive property, fractions, solving for a ratio, inequalities, converting what's given to what's asked, and solving for a parameter. And these are problems that you'll most likely see on the easy part of a test. They're just testing traditional algebraic operations. You want to spend enough time on these to make sure you get them, but you don't want to spend excess time, because these are problems where you'll build up a time reserve that you can use on harder problems. These are problems in the SAT official guide, the Blue Book, where you could find these types of problems. The notation here is practice test 1. This is problem section 3, problem 7, section 3, problem 16, and these notations R is a ratio problem, I inequality, C converting given to answer, and P solving for a parameter. You may want to save some of these to do as complete tests, but the rest you can use to practice these types of problems. Let's look at some problems. If you want to try this on your own, you can pause the screen now. So this is a problem where you have to translate the words into algebra. So we have 5 more than something is, which means translates to equals 29. So what is that something? It's 3 times a number. So 5 more than that number would be 3n plus 5 is equal to 29. Subtract 5 from both sides. 3n is equal to 24. Divide both sides by 3. N is equal to 8. Fairly straightforward high school problem. The next problem type is where you have an unknown on both sides of an equation. If you want to try this on your own, you can pause the screen now. So 7 less than something equals 13 less than something. Sometimes it helps to work these backwards or inside out. Twice a number would be 2n. And less than sometimes throws people, so if you're not sure, think of it with specific numbers. How would you do 7 less than 10? 10 minus 7. So this is 2n minus 7 is equal to 13 less than 5n. And if you have the unknown on both sides of the equation, you want to subtract it out from one side at first to eliminate it from that side. And you want to subtract it from the side that has fewer, so it ends up being positive on the other side. So we add 13 to both sides. We get 3n is equal to 6, n is equal to 2. But you always want to take an extra second to make sure you're giving them exactly what they want. Sometimes you're so happy that you get an answer, but you forget to notice that that's not exactly what they want. What they want here is not n, but 9 times the number, which is 18. And that would be the answer. Next, the distributive property. And you're going to be seeing probably at least one of these on every test. If you want to try this on your own, you can pause the screen now. Okay, so distributive property is just everything inside the parentheses gets multiplied by what's outside. This gives you 3x minus 15 is equal to x plus 10. Subtract x from both sides, we get 2x minus 15 is equal to 10. Add 15 to both sides. 2x is equal to 25. Divide by 2, x is equal to 12.5. Pretty straightforward. Next, if k times a plus b is equal to 20 and k times a is equal to 8, what is k times b? So distributing, we get ka plus kb is equal to 20. And everything in an SAT problem is there for a reason. Why do they give you this? Because it goes there. And subtract 8 from both sides. K times b is equal to 12. With fractions, you don't want to worry about common denominators and such. The easiest way is probably to convert them to decimals. As usual, if you want to try this on your own before looking at the solution, you can pause the screen now. So which of the following is equivalent to 0.8 over 0.54? Well, if you do that division, you get 1.481 repeating. So you just want to check the answer choices. 0.2 divided by 0.8 is going to be 2.5. This is going to be 3. That's 1.5. And here you'll get 1.481. So that's the answer. Next fraction problem. If you want to try this on your own, you can pause the screen now. With fractions, you want to avoid finding common denominators. So here, you could convert these fractions to decimals, and if you added them, you would get 1.805 repeating. X is equal to 130, and divide both sides by 1.805, you would get x is equal to 72. But you want to keep all of your calculations in the calculator. You don't want to have to re-enter them, because then that could create some rounding error, particularly for grid-in problems. If you want to solve this algebraically, you want to multiply both sides by what will get rid of the denominators. And if you think in terms of prime numbers, to get rid of the 4, you need 2 2s. To get rid of the 6, you need a 2 and a 3. To get rid of the 9, you need 2 3s. And if you multiply those together, you get 36. And if you distribute that through, you would get 27x plus 30x plus 8x is equal to 130 times 36. And you don't necessarily want to do intermediate calculations, because, as we'll see, it makes it easier to cancel things out. So if you add the x's, you get 65x is equal to 130 times 36, and if you divide both sides by 65, 65 goes into 130 twice. 2 times 36 is 72. Next fraction problem. If you want to try this on your own, you can pause the screen now. If 2/5 of n is 10, what is 3/5 of n? Well, you could do it algebraically. 2/5 of n is equal to 10. So if you want to do this as decimals, that will give you 0.4n is equal to 10. Divide both sides by 0.4, and n would be 25. And you could also have done it by multiplying this by its inverse, multiplying this by 5/2, and then multiplying this by 5/2. Okay, so now we have n, now 3/5 of n, so 3/5 of 25. 5 is in 5 times, 3 times 5 is 15. Another way of thinking about these is as a proportion. If 2/5 of n is 10, then 1/5 would be a half of that, and 3/5, well, this is 1.5 times that, so this would be 1.5 times that. Next fraction problem. You could pause the screen if you want to try this on your own. If 3/4 of a number is 600, what is 1/8 of the number? So again, algebraically, 3/4 of n is equal to 600. You could multiply by the inverse to get 1n, so we have to multiply this by 4/3. 3 goes into that 200 times. 4 times 200 is 800. What is 1/8 of the number? Well, 100. Again, you could have done this as a decimal 0.75 of n and divide both sides by 0.75. We'll be doing percents under a separate topic, but you can treat percents as a fraction. If you just remember, it's 100 in the denominator. So 1/1200 times some number is equal to 1,000, or 0.12. If you divide it by 0.12, you'll get something like 8333 repeating. And particularly for a grid-in problem, you want to keep your answer in the calculator, because then you want to multiply that by 0.15, and you'll get 1250. And you could also do this like a proportion. Let's see, 12% is to 1,000, so twice the percent would be 2,000, and so on. So if the multiples are somewhat easy to calculate, so like 15 is, let's see, 1 1/4 times 12, so this should be 1 1/4 times 1,000, or 1250. This is the end of the first section on solving for unknowns. In the next section, we'll be looking at solving for ratios, inequalities, converting what's given to what's asked, and solving for a parameter.